Hi everyone, Professor Bob Young here, and in this instructional video we're going to talk about graphing some linear inequalities and systems of inequalities. Now, a linear inequality in two variables, it's kind of like when we're doing linear equations. We had standard form, slope-intercept form when we were graphing and so forth. But linear inequalities are in this form usually, which we'll show you. You can adjust. AX plus BY is less than or equal to C. Now, most of you are used to seeing that with just the equal there, but oh, those inequalities. All kinds of fun happens when those come into play. And of course, A, B, and C are real numbers, with A and B not both equal to 0, because if they were, we'd have a little problem there. Now notice that symbol less than or equal to could be replaced. It could be greater than or equal, less than or greater than. The graph of a linear inequality is usually a half plane, a collection of points that satisfy the inequality. And it'll be bounded, as we will see there, perhaps with a boundary. All right, so let's get into it here. So to graph this first linear inequality, 3x minus 2y is less than or equal to 6. Now, what we're going to do here is act like, well, this is standard form. Act like this is an equal sign right in here. All right, and when we were graphing in standard form, and this is good review for the whole chapter, we let x be 0, and then we solve for y. So do y'all see if you plug 0 in for x, and this, if it were an equation, y would be -3, and there is the y-intercept. Now, to do the other one here, to get the x-intercept, let y be 0, and if you plug 0 in for y, then x would be 2. So you probably had enough practice getting the lines and so forth here. All right, now notice here, since you do have that less than or equal to, it says since the points of the line satisfy the equation, this line is part of the solution set. So I put some notes down here on the bottom. So for if you have less than or equal or greater than or equal, you'll always have solid line figures. All right. This means that all points on the graph will satisfy the inequality. So for example, if I took this point 2, 0 up top here and I plugged it in to this inequality, x would be 2, I'll just stick that under here, y would be 0 here, we would get the inequality 6 is less than or equal to 6, which is true. So any point we pick on that line will satisfy this inequality here. Now, notice if there was no equal to, for just less than or greater than, you would use what's called dotted line figures. A line would not be solid. And that means that no points on the graph will satisfy the inequality. Now, do you see if that top statement had just been a less than, then we would have ended up when we started plugging those points in here with 6 is less than 6, which does not make sense. It's a false statement. So that's why lines are either solid or dotted. You know, it either includes all the points on it or it does not. But we're not done yet, ladies and gentlemen. Let's do something from previous sections here. We could have taken this standard form inequality and solved it for y here by subtracting 3x from both sides. So we'll just go ahead and change from standard form to slope-intercept form, which a lot of students like to do. And then to get y, we'll go ahead and divide everything by -2. Now, here's something that some of you missed earlier on that will just kill you here. Whenever you divide an inequality by a negative number, and this is something y'all missed, some of you, not all of you, but some of you missed earlier, and this will be on the final, be sure to flip that inequality. All right, so we could have rewritten this as y is greater than or equal to 3/2 x minus 3. And let's go ahead and put that here. I'm going to go ahead and put that y is greater than or equal to 3/2 x minus 3. Now notice in this form we would have started at the y-intercept, -3 down here. So remember that's b, y-intercept. And then we would have used the slope m. We would have went up 1, 2, 3 over 2. So we would have did the old rise over run here. And then we would have had that solid line again. All right. So now, where do we shade, ladies and gentlemen? All right, where do we shade this thing here? So let me just come back and forth. I just wanted to erase all that on there real quick. The solution set of this is either everything shaded one side of the line or the other. So what I tell students to do is use a test point, a checkpoint on where to shade. And I think the easiest point to check, just the lazy person's way, is check the point 0, 0. So if I plug 0 in for y and 0 in for x here, I'm going to get, well, 3 times 0 minus 2 times 0 is less than or equal to 6. 0 is less than or equal to 6. Notice this is true. Our friend 0, 0 passed the test. Any point you pick on this side will satisfy the inequality. So this is called the solution set of a linear inequality. Now, if you would have picked a point over here and tried it in our problem, this would have not been the happy side. It would have been, So let's just do it for fun here. Let's take this point over here and check it. Let's take the point 3, 0. All right. So if we had our original problem here, and it would work in the slope-intercept form as well. Notice if we put 3 in for x and 0 in for y, we get 3 times 3 is 9 minus 2 times 0 is 0 is less than or equal to 6. See, no point on this side will satisfy. So that's why you shade what works. I like that saying. Let's say it again. Shade what works. Don't shade what don't work. Don't you love these sophisticated things I gave you? Now, I snuck ahead here, and now a blast from the past. Y'all are really going to like this. They're going to throw the old and or back in on you, and some of you had trouble with this earlier. So again, if I don't get you the first time, I'm going to try to get you the second time. All right? Now, remember, whenever you see the word and between two things, that is the intersection. That means the intersection of what happens with these two inequalities. And I don't know if y'all remember that. Some of you missed it on one of the tests earlier. Intersection means what they have in common, what both have in common. Okay? Another word I like to use for these is the word overlap. Where do the two graphs overlap? That's the solution set of this one. So I picked a few kind of nice lines here, and I threw some things in here. So let's start with this first inequality here. X plus y is less than or equal to 5. Now, I don't think this is going to make anyone go brain dead. So if I put 5 in for x, hopefully everyone sees y as 0. And if I plug 0 in for x, y will be 5. And I'll go ahead and plot those 2 points here. I want you all to think here, solid line or dotted line. And this symbol right here should help you with that. That will be, ladies and gentlemen, drum roll. Oh, sorry, they're rattling. Solid line. So let's go ahead and make it. So all the points on this line will satisfy this inequality. So if I put 0, 5, or 5, 0 in there, I would get 5 as less than or equal to 5, which is a true statement. All right, now we're not going to shade anything yet. Now, if this were the only problem we were doing, where would we shade? Above or below the line? Well, let's check the point. What's an easy one again? Oh yeah, lazy young, you are just so lazy. 0, 0. So if I plug 0 in for x and 0 in for y, true or false, deal or no deal? I used to like that show there with Howie Mandel. Deal or no deal? It is true. Deal. So if we were going to do this one, since 0, 0 works, we would shade toward 0, 0, because all of his buddies over here, every single point with 0, 0 below this line will satisfy that inequality. Ladies and gentlemen, don't believe me? Try it on your own. Check some other points. All right, now I'm going to go different colors. You know I like to go different colors here. We're going to go blue for our second inequality here. So this is in slope-intercept form. Good review. I'm going to start at -2 and tell me where to go. Mathematically, that is. I know some of you go, I'll tell you where to go, young. So use this slope And we're going to put rise over run there, remember, in this slope-intercept form, and we're going to rise 1, run 3. So I'm going to put my dot there. There's how you get your 2 points in slope-intercept form. So in standard form, you can get your 2 points for the line by using the intercept method, and in slope-intercept form, we're going to use the rise over run. Solid or dotted line, ladies and gentlemen. Think about it. Dotted, I can't make it dotted lines as good on my writing tablet here. Sometimes it gets, I'll try to make it as straight as I can. I guess that's close enough for government work. All right. Now, where would we shade this blue line? What point could I check? 0, 0 perhaps? So if I plug 0 in here for y and 0 in here for x, is 0 greater than -2? I do believe it is. I do believe 0 is greater than -2. It's greater than any negative number. So I'm shading again. 0, 0 has worked both cases, ladies and gentlemen. We're going to shade toward it again. All right. Now, with the and there, where do these two graphs overlap? This is where in Math Excel you would drop your bucket down if you had buckets to shade. I like Math Excel. That's fun. So everything below the red, everything above the blue, here is what you would shade for the solution set. Only where they both happen. Only where they both have something in common. All right, these are fun, huh? And you can use colors too and have all kinds of fun here. Let's try another one, but let's use the word or between them this time. Now remember, or is totally different than and. Or, if you remember from earlier lessons, uses that union symbol. Union does not mean what they have in common. Union, remember, means combine everything together. So I'm going to write that, combine everything together. So you are going to shade everything that works for both of these two lines. All right, so let's start, and we'll make this first line in pretty blue here. And notice I picked slope-intercept form again. So I'm going to start at 5 and tell me where to go. -3/4 is the slope. Go down 3 and right 4. And remember, a negative slope usually goes this direction. Solid or dotted line? Dotted. Why? Because it's a less than, doesn't have the equal to. Sorry, my line's a little crooked again. You don't know how difficult this is on the writing tablet. Check 0, 0. If I plug, some of you already know if it's going to work or not. You're ahead of me because your minds just flash here. But Young likes to show his work. Y'all know that. I would get 0 is greater than 5. I don't think so. 0, 0 has failed us this time. It's not true, so we're going to shade away from 0, 0. Of course, we're not shading anything yet. Excuse me. All right, now, notice I slipped a little second line in here, which we're going to do in pretty green. Y is less than or equal to 1. All right, now which way does a line go that crosses Y here? Well, it is going to go through Y at 1. So I'm going to go ahead, and of course it's going to be a solid line. I hear my daughter trying to call me. You never know what you're going to get on these videos. I'll have to call her back. All right, you're going to get a solid line through Y at 1 there. So I'm going to put that. Why is it solid? Oh, it's got the equal to in there. So all the points where Y is 1 is there. Where do I shade this one, above or below? Well, since it's less than, all the numbers less than 1 on Y, we would shade below. Now here's the good thing on this, ladies and gentlemen. Since we have the or symbol, we're going to shade everything that works in both lines. So I'm going to shade with orange here. I just like to pick different colors. We're going to shade, since it's or, everything that goes this way on the blue line. And everything that goes this way on the green line. That's what OR does for you. You put that bucket all over the place. You have to put it, I think, in 3 spots here in this one. Now notice if this had been an and, where would you have shaded? Do you see where they overlap in here? Had that been an and I'll kind of do this. Let me find a different color here. I'll find red, I guess, where this would be the best contrast. And would have only been shaded in here. See, that's the only places those would have overlapped. So do you see the huge difference between and or? So that's how they differ. And then it's basically the same thing. All right, now when you go on to chapter 4, later chapters or something, you're going to get into something called solving systems of inequalities. Now, I think in your book that will be section 4 or 5, but I'm making these videos globally, so it could count for anything. So when solving systems of inequalities, there is no and/or between the inequalities. And what you must know on these, if you don't see the and or, ladies and gentlemen, this is huge. It always means and. All right, so keep that in mind. Always means and, if you don't see one. All right, which means what they have in common, where they overlap. So I wanted to do one more example real quick here. So we'll start out with this standard form, and we'll do it in red. Or no, let's go different color here. Let's go orange on that. So we're going to act like it's equal again. So when y is 0 there, since it's in standard form, x would be 2 to get the 8. When x is 0, y would be, watch your signs there, -4. And of course, you could change that to slope-intercept form and so forth as well, solve for y, but you have to watch that flipper rule. Solid or dotted line here, this would be solid. So I'm going to go ahead and put that. So this is just one more example here. I think once you start doing enough of these and you're graphing enough that life will be good, you'll have these here. That's a little bit better, straighter line. Now let me let y'all think about this. Will 0, 0 work on this or not? Let's do some mental math here. Plug 0, 0 in there in your mind for x and y. And I think you better come out with, yes, it does work on this one. So we're going to go ahead and shade this way. Now, a student the other night asked me, what if it goes through 0, 0? Young, what if the line goes through there? Well, then you just pick any other point. You pick like 2, 0 or -5, 0 or 0, 7 or any other point you want. And that'll tell you if it works, shade there. And if it doesn't, don't shade there. All right, so that was a great question. Now we're going to take a nice violet color here, and we're going to do the second line here. If x is less than -2, which way does the line go that has x as points here, and it's solid or dotted? It's going to be, it's going to go through x this way, -2. Remember we had one earlier that went through y. That's my little dotted lingo there. Which way would I shade this one? Well, since it is left or less than -2, it would have everything this way shaded. So if this one said solve the systems of inequalities here, you would have to know it meant and. Where does this overlap, ladies and gentlemen? We're going to get the pretty green back out. It would be everything in here that where these two would overlap, and only in here. If you try to shade anything else, no. And above this line here too. So you don't want to go below that line either to get what's in common. All right, so this was graphing linear inequalities and systems of inequalities. Let's start hitting it on the homework, and you should be close to wrapping up the graphing as far as the course is concerned. Bob Young signing off.